Hello everyone, in this quick tip I'm going to show you how you can get the silhouette of a 3D object in camera space. So you can get a nice outline edge around an object and use that to create various different effects. In this case I made some weird ethereal flippy, but you can use this for a lot of other different stuff. To start us off with, I've got a camera and I've got a geometry called toy, which is our rubber toy flippy. And I've got a attribute delete just to clear off some attributes. So we just have a gray flippy and a transform so he can rotate around. And then I'm object merging flippy into an object called silhouette, which is our starting point for this. And what I'm going to show you how to make is something like this HTA that I put together, which right now doesn't look like it's doing much. Let's just, actually I'll keep that and just, he's on ghost already, so that's okay. Just hide over objects. And you can see it's set to distance from edge, which gives us an attribute called dist. And if I middle click that, you can see that I'm getting this distance from the edge. I could also pick outline, give us an outline that nicely matches the incoming geometry. And I can also choose flat card, which is the same as outline, except it's filled in. So this is getting the outline, which is different from getting the facing ratio, where you'd compare the normals to the direction of the camera. I'm not going to go into detail on this one, but you can see the code over there. And you can see you also get a kind of an edge effect, like it looks very much like Fresnel on a shader. And that gives you a similar effect, but you can see you're also getting some values on the inside of the object. And this is cool, but in this case, we just want to get the outline for a more graphic effect. Before I dive into the setup, I should point out there is the lab silhouette tool, called lab silhouette or extract silhouette, which gives you something similar, like it gives you a card, and you can do it based on an axis, and you can also do it based on an orthographic camera, which, as you can see, if we give it a regular 3D camera, like it doesn't actually give us the result that I'm looking for. So if I show the other object, you can see we are getting a card, but it doesn't perfectly match our object because this is a perspective camera. So I'll get rid of extract silhouette and show you how to put this one together. The first thing we'll need is to get a rest position. And that's just going to be to store our current position. And in this case, I'm not going to use this as a rest, that always stays the same. So I'm just going to give this a different name. I'll just call it pause. So you know it's something that we can delete later at the end of our setup. Next, I'm going to get a wrangle. And don't worry, it's not too much code. And I'll call the wrangle flatten in camera space. And in the wrangle, I'm going to create a couple of variables. The first one's going to be a string, and I'll call that camera. And that's going to be equal to a channel, which is going to point us to our camera string. And I'll also create a float, and the float I'll call depth. And that's going to be our other input channel, which is going to be a float. And I'm negating that, and I'll tell you why in a second. And I'll call this depth. That's going to be our inputs, and I'll just create that. And I'll set the depth to 1. And I'll point the string to our camera. Okay, so the reason I set this to negative is we're gonna convert our position to normalized camera space. And by default, camera Z in Houdini points in the negative direction. So -1 would be in front of the camera. So I'm gonna take the position, and then I'm gonna use the toNDC function. And NDC stands for normalized camera space. So we're going to convert this position into a normalized camera position. And we're going to use that camera string, and we're going to use the current position. And if I hide our flippy, you'll see our geometry has disappeared. If I middle click, we can't see it. And if I leave the camera, you can see it's got this weird offset position. And now, while it is in a normalized camera space, we want to set the position to the depth, which is going to flatten it. And that's going to be the position along Z, like that. So we get this flattened flippy, and we can see it's in a normalized 0 to 1 range because everything is in camera and it's sitting at -1. So now we want to put that back into a position that makes sense. To do that, we use the from NDC function. So we're converting back into a sort of a walled space after making that transform. So we again use that camera string and use the position. Now we'll see Flippy is moved and he's been flattened in camera space. And if we turn on the other object, we can see we don't see a difference because it's perfectly flattened in the correct direction. So I'll hide the other object again, or actually let's show all of it, because we can see the camera now. You can see big Flippy at the back and flat one in front, and this depth slider is going to control where he gets projected. And really that's most of the hard work done. Now we just need to get an outline and measure the distance from that. So to do that, we need to clean up this geometry and turn it into something useful. We'll get an attribute to delete. Just to get rid of some of the attributes I'm not going to need. So we can get rid of the normals. And that should do it for now. And then I'll get the 2D triangulate node. Or triangulate 2D, and this is a very powerful node. I'll stick that in there, and by default, it's already doing a pretty good job of cleaning up this geometry. The only problem is we're getting this convex hull. Luckily, the latest version of the 2D triangulate has an option to use the silhouette. So I'll turn on silhouette and I'll set it to star, so to use all. And you can see we get this group for the silhouette. Let's be all the points around the outline. Whoops. So to clean up our remesh based on that, we need to go to outline removal, and we want to flood from the convex hull boundaries, and then just to be safe, we want to remove outside of silhouette, and you can see we get this nice silhouetted geometry. From there, we can use a divide sub. And with that one, you can remove shared edges. And now we just have a flat card. And with a polypath, we can turn that into a line. Something like that. Now we got this perfect outline, and if I look through camera, see where it's sitting. And now if we want to measure the distance, we need to measure it on flattened Flippy, which we have already got over there. So now we can get the distance from geometry. Take that in the first input and that one in our second input. And then we can set this to distance from geometry. Now if we just visualize that distance, you can see we get this flattened distance in a 2D camera space. And the last thing you need to do is get another rest. And we can convert that back into its original position using that pos attribute and setting this to swap rest. And now I think we're just seeing our flippy. Yes, so if I hide that, that's the whole setup complete, and we get this camera space silhouette attribute. Alternatively, you can use this polyline, or you can use this flattened card. One thing to watch out for with the flattened card is if the geometry has a hole inside it, you probably want to use the whole sub after this, which will clean up any holes. And let me just show you what that does. It's easier if you see it. So I'll create a tube and cap it. I'm just going to template flippy. Make the tube a bit smaller. Set it on Z. And maybe just rotate it to position so we cut a hole inside of him. And just scale up that height and boolean it. It should give us a cut right through him. And we should be able to see through. So now if we flatten that with the divide, see we don't see the hole in there, but as soon as we run it through the whole sub, it figures out the winding order and removes the area in the middle that needs to be removed, because there is geometry there. So if we look at the divide, it's a bit hard to tell. Oh yeah, you can see it from there. So it's like overlapping geometry from trying to mesh this one giant really dodgy polygon. And the whole sub fixes that for you. So that's the 3 different outputs, and that's it for the whole quick tip. And I can quickly show you the particle setup, but that's super basic. And if you're just watching this to check out the silhouette, then you can stop here. But we'll just get an attribute remap. And I'm just going to remap that distance attribute as an emission source. Set that to 0 and 1. And I just want to choke that right down. So we get this edge value, something like that. And actually that should be 1 and 0. And then I can just do the blast. And in the blast node, I can pass by that attribute. So I'll say at this less than 0.5. And that needs to be a point group. If you're using an expression, you have to specify the geometry type, otherwise it's not going to work. So there we get some geometry now. So after the blast, we can scatter some points, or alternatively, if I scatter, you can also just use that attribute directly as a density attribute. Since I've already deleted those, I'm just going to do that. Set it to say like 10,000 points and get a pop network, and I'll also get a point velocity. And I'll just give it some curl noise. Get the value down to like 2.5 or something. And maybe reduce the swirl size to 0.5. Stick that into the first input. And now if I hit play, we should get not too much happening. I should just set this to particles. Now we should get some emission. You See, we do get some emission now, but it's getting a little bit crazy because I forgot on the point velocity. Go back to the first frame. It's trying to compute the velocity, and I'm deleting points, so that's not going to work. You either need to compute the velocity before, or just remember to turn off keep incoming, or you need to keep the incoming velocity if you have it, but you don't want to compute the velocity on deforming the geometry, which is changing every frame, and because the camera is moving, we're getting a different, although because Flippy is rotating, its point count's changing. So I'll just set this to set value because I don't have any incoming velocity. And the simulation didn't reset, so let's just do that. And I'll hit play, and you can see now we're emitting some particles only from the silhouette. He's turning around, so we do get some stuff covering him. But I think you get the general idea. You can make all kinds of cool effects with this. Lifespan down. And show all geometry. Set this to point so we can see it a little bit better. And I'll just play a couple of frames, and you can see the effect we're getting from this. It's pretty cool, and you can do lots of cool stuff with this. I hope you enjoyed this quick tip. Thanks. Bye. If you want to see more videos like this, or if you just want to support me, go check out my Patreon page, or follow me on Vimeo or YouTube. And if you like this video, give it a like. And as always, to all my patrons, thank you very much for your continued support. I can't do this without you guys.